Alright, so for this one, we're actually going to start with a question. Moons with retrograde motion have likely A. formed around the planet through accretion, B. changed orbit due to a giant impact, C. been captured by the planet's gravity, or D. changed orbit due to orbital resonances with other moons. Go ahead and think about it, and we'll discuss in just a bit. If you remember, a moon with retrograde orbit means that it is orbiting backwards around a planet. A giant impact that would have enough energy to cause this would also have enough energy to completely destroy the moon, so although we do like giant impact to explain a lot of our weirdnesses, this one simply won't work. The best explanation is C, that it was captured by the planet's gravity. So the reason I point this up, the asteroid belt isn't the only location that has asteroids. Previously, we've mentioned that all of the Jovian planets appear to have moons that have actually been captured, either captured asteroids or comets. Jupiter not only has many moons that appear to be captured asteroids, it also has two regions of asteroids within its orbits. These are at special points referred to as Lagrange points. These places we have a balance of gravity between the Sun and Jupiter pulling on these objects. So these places are actually regions of stable gravity. Once an object has fallen into this region, it actually wants to stay there. So we have these two pockets of asteroids leading and following behind Jupiter. These groups of asteroids are referred to as the Trojan asteroids. Not only do we have asteroids out beyond the asteroid belt, but some asteroids in the asteroid belt have long elliptical orbits that cause them to come in towards the inner solar system, past the orbit of Mars, Earth, Venus, and recently we've even found a couple that go inside of the orbit of Mercury. Now these ones that cross by the orbit of the Earth we refer to as near-Earth objects, or NEOs, and these are the ones that we're very, very interested in finding all of them. The reason is, these are the ones that have a chance of actually impacting the Earth. Now, some of these do get very close to the Earth. In 2013, there was one of these things that actually crossed closer to the Earth than our moon. In fact, this actually happens more frequently than we like to admit. Now, some of these are actually more worrisome because we haven't actually found them before they get that close. Now, that being said, we are starting to track more and more of them, so you don't really have to add impact to the list of things that you worry about. Now, the Earth does occasionally get hit, although the Earth does have very few craters. That is because of the Earth being geologically active. Here is an image of Crater National Park in Arizona. This crater was formed about 50,000 years ago when a 50-meter across asteroid hit going at 11 kilometers per second. And to give you a sense of scale for this, that right there is actually a road leading up to the rim of the crater. As geologists were going through looking at different sedimentary layers across the Earth, they actually found one layer that was rich in the rare earth element iridium. So we have this layer of sediment that seems to cover pretty much many different regions of the Earth. Well, again, iridium is a rare earth element. It's rare to find just on the Earth. However, we have found that it is actually common in asteroids and meteorites. Well, as they went through and figured out the age of this sedimentary layer containing iridium, it dated back to about 65 million years ago. Well, if you remember, 65 million years ago is the time of the extinction of the dinosaurs. This is what first led to the idea that maybe it was a giant impact that actually led to the extinction event that led to the end of the dinosaurs. This was later given more credibility when we actually found the crater. The impact crater, known as the Chicxulub crater, found in the Yucatan Peninsula of Mexico, fits the age and the description, the scale necessary to be the impact crater that actually led to this. In 1908, there was a giant explosion in the Tunguska region of Siberia, so this is far eastern Russia. Now, this blast was so large that it knocked a man off of his porch that was 60 kilometers away. So imagine an explosion in Salt Lake that was so big that it knocked you down here in Orem. The blast was also so loud it could be heard over 1,000 kilometers away. In other words, this thing was really, really big. Now, unfortunately, this happened during a time of political unrest and also the lead up to World War I. Because of all of these things, it actually took over 20 years for scientists to finally get out to the area to start investigating and trying to figure out what actually happened. One thing that they found in this region was even 20 years later, there was a huge section of forest that had been completely flattened in what we refer to as a radial pattern. What this means is all of the trees were pointing away from one central location. What this means is we know exactly where the blast happened. Now, one big mystery, even somewhat still from the Tunguska event, is that there's no impact crater. So, because of that, there's been widespread speculation. One of my favorites is that Nikola Tesla, if you know Tesla, he was a scientist inventor in the early 1900s. He was active around 1908. One of the things that he was actually known to be trying to do was to be able to broadcast electricity, so to actually send electricity wirelessly from one location to another. So the speculation is that in one of these events, one of these experiments where he was trying to send electricity from one place to another, he actually miscalculated. It was a much larger amount. It arced over the pole and exploded over Siberia. No, this is not what happened, but I love the idea. Another one that I've heard is that it was caused by a miniature black hole. A black hole fell into the Earth's atmosphere, started pulling in so much material so quickly that it exploded. Because that's what black holes do, right? They explode when pulling stuff in. Okay, so enough with the fun, crazy ideas. What we do believe actually happened was it was an impact. However, the meteorite actually became superheated as it fell through, that it exploded into tiny fragments before actually landing and making the giant impact crater that we expected. This has recently been given more support because of the micrometeorite fragments that we've been able to find in the area. In 1992, there was a large crashing sound outside of a lady's house. Running outside to try and figure out what had happened, see if there was somebody who needed assistance, she found that there was a car crash, but in this case, a meteorite had crashed into her car. Now, unfortunately, most insurance isn't going to pay for this. This falls under the Act of God clause, so that was very disappointing. So we do see that the Earth still does get hit today. However, the frequency of the impact is going to be related to the size of what's actually hitting us. So on this graph, up and down, we're looking at time. So at the top, we're looking at an hour and then a day and so on, down to once ever in the Earth's history. And then along the bottom, we're looking at the size of what's actually hitting. So over here on the far left, we're looking at relatively small things, and then we're getting to larger and larger things as we move to the right. So when we look at really small things like the size of a grain of sand, this is occurring a couple of times a day. If you've ever seen a shooting star, that's actually a grain of sand, a grain-sized piece of space debris hitting the Earth's atmosphere and burning up. Getting to something that is large enough that it might actually lead to what's sometimes referred to as a fireball, and that could actually lead to a crater, this occurs every 10 to 100 years or so. Something that is big enough that could actually lead to a tsunami or some widespread devastation occurs every 100 million years or so. Something that actually leads to a mass extinction, like what happened with the dinosaurs, we're looking every couple of billion years to once ever in the history of the entire Earth. So again, when you suddenly pop up awake in the middle of the night in an existential dread, worrying about all of the different things that could possibly kill you, you do not need to add a giant impact to this list. All right, here's our third clicker question. What do we believe made the dinosaurs go extinct? A. Global warming, B. Global freezing, C. Giant meteor impacts, or D. Overhunting by early hominids? Go ahead and think about it, and we'll discuss in just a bit. All right, so although dinosaurs were probably very, very tasty, we actually know from the geologic record that humans, any human ancestor, and dinosaurs never actually lived together. So the correct answer is C, giant meteor impact.